right? So we'll look at divisibility now quickly. Concept one is divisibility by 2 power n or 5 power n, right? So it's a standard thing where we just need to find out the uh, last n digits and check if it's divisible by 2 power n, right? If you want to take up an example, what's the remainder of 4759 when divided by 25? 25 is nothing but 5 square. So 2. I'm concerned only about the last two digits. What's the remainder of 59 by 25? And that's going to be 9. 9 becomes the answer here. What if I'm required to find for 8 over here? 8 over here, I'm concerned only about the last three digits, right? Because 2 cube over here, 2 cube, the power is 3, last three digits, ignore 4. So it's remainder of 759 by 8. 8 nines are 72, left with 39, and 7 is what we get. 7 becomes the answer here. Okay, so moving to the next concept, right? Divisibility by 10, right? So this is the simplest, or a 10 or a 10 power n, right? It's simply the last n digits, right, of that number. So if you want to take up some big number like 354 954 divided by 1000, three zeros, right? 10 power and 10 cube, then it's simply the last three digits, 954. That's it. You don't need to divide by 1000 and see, because 954 is going to be less than 1000. Number of zeros, that many digits you place, and that's divisibility by 10 power n over here. Okay, so moving to divisibility by 3 and 9, or 3 or 9, right? So we know we need to look for the sum of digits, right? Sum of digits. The proof I'm not going to get into right now. We've seen that in the lesson, right? So just refer to the lesson if you want to understand why. We just need to work with the sum of digits over here, and that's it, right? So if you want to find the remainder of 3, 4, 5, 6, 7 divided by 9, what is that going to be? 3 plus 4 plus 5 plus 6 plus 7. We can just add up the digits. That's going to be 12, 18, and 7, 25 by 9. And comes to, once again, add up the digits. 2 plus 5, 7. Right? Don't divide and see. You can keep adding the digits to get it. Now, can you do it directly from something like this? Yeah. Wherever it adds up to 9, ignore it. 4 and 5, 3 and 6 are 9. You're left with 7. 7 becomes the remainder here. The same when you divide by 3 as well. All right. Once again, any multiple of 3? Yeah. Any multiple of 3 when you add up? Yes. 7 by 3. Remainder is 1. 1 becomes the answer. Right. 3 and 9, just the revision, going through quick with this. I'll just refer to the lesson to understand detail. Yeah. Divisibility by 11, right? To check for divisibility by 11, you just need to go with the plus minus types, right? So if you have 3, 4, 5, 6, 7 divided by 11, plus for the rightmost end, then minus, then plus, and then minus and plus. 7 minus 6 is 1. This is also 1. 1 plus 1 plus 3, that comes to 5. 5 becomes the remainder here. Okay. Now, at this stage, you could get some questions around this, right? Not using 11, but something like 101, right? Or 99. How do you do it? So what is the remainder of, let's say, 4141414141 4, right? How many 4 ones over here? 5 4 ones and a 4, right? That's a 11-digit number divided by 99, right? Divided by 99. What is the remainder going to be, right? So we need to understand that this number, now 99 is what? It's close to 10 square, right? 10 square. So this number over here can be written as, the number can be written as 14 into 100 power 0. Then the next 14 into 100 power 1. The next 14 over here into, from the rightmost end we have to start, 100 square. 14 into 100 cube, 14 into 100 power 4 plus 4 into, right? Yeah, 4 into 100 power 5, right? You don't need to write all of this. It's just noting this the first time around. The proof which we used for divisibility by 9 or 11, the same we have to use for 99 or 101, with 100 over here, right, instead of 10. Now, when it's going to be 99, what is 100 power n by 99, right? The remainder is going to be base by this. That comes to 1. 100 by 99 remainder is 1. 1 power n is 1. So everywhere we're going to be getting, all these are going to get cancelled. We're going to get 1 everywhere. So this is nothing but, the remainder of 4 into 1 plus 14 into 1 plus 14 plus 14 plus 14 and plus 14 everywhere. These 100 power n divided by 99 remainder is 1. 1 into 14 everywhere. And we get this. Now, what is the sum of all of this? 14 into 5 plus 4. That's 74 by 99, which is 74 itself. Now, how do we do this very quickly going forward? When your divisor is going to be 99, remember 2 digits at a time, you can take up and add them up. That's it. Sum of 2 digits at a time from the rightmost end. 14 plus 14 plus 14 plus 14 plus 14, 70, 74. 74 by 99, answer is 74. Don't need to do all of this. Now, likewise, a bonus one. What if it's divided by 101? Starting with 4, 14, 14, 14, 14, 14, right? With 101, it's one more. Look at this. What is the remainder when 100 power n is divided by 101? 100 by 101, negative remainder is going to be minus 1 power n divided by 101, right? So minus 1 over there. So if it's going to be minus 1, something like 11 divisibility. So 100 power 0 by, if this would have been 101, right, it's going to be 1 itself. 100 power odd number, odd n, it's going to remain minus 1. If it's even, it's going to be plus 1. Odd is minus 1. So it's going to alternate plus, minus, but 2 digits at a time. 2 digits at a time plus, 2 digits at a time minus, 2 digits at a time plus and minus. Plus 14 minus 14, they're all going to get cancelled. Plus 14 minus 4 comes to 10. 10 becomes the answer over here, right? So likewise, you could extend it to 999 or 1001 and so on. But 1001 is what is used over here for divisibility by 7 and 13, right? So if you take a number, which what has been used in the lesson, 3594, right? 248 is divided by 7, right? What is the remainder when it's divided by 7 over here? 7 or 13, this is the thing, right? Given that 7 into 11 into 13 is 1001. 1001. 101 you took 2 digits at a time plus minus. 1001 you go for 3 at a time plus minus plus, right? Plus minus and plus. And what's 248 minus 594 plus 3? 248 plus 3 is 251. And you subtract, you're going to get a minus 343. And is that divisible by 7? Perfectly, right? So you get 0 is the answer over here. For 13, you can try it out, right? I've seen this in the lesson. Okay, moving to the next concept. You don't want to spend too much time on this, right? 7 or 13 don't turn up too often. Okay, now divisibility by other composites. What are the other composites we could have? Anything, mixture of primes, right? So if you need to check if 3000 is going to be divisible by 36, right? Is it divisible by 36? Perfectly. 36 over here can be written as what? Prime factorize it. 2 square into 3 square. Is 3000 divisible by 2 square? Yes. Is it divisible by 3 square? By 3 it's divisible, not by 9. So therefore, no, it's not divisible by 36. So to check for divisibility by composite numbers, then you'll have to prime factorize those composites and take each prime chunk with those powers and check for the divisibility. Now moving to the next concept over here, the largest power of a prime that divides a factorial, right? What is the largest power of a prime number that divides a factorial? Take a simple example. What's the greatest power of 5 that perfectly divides 100 factorial? Take 100, what we have seen, successively divide by 5, right? And note down the quotients, right? 20 and 4, then it becomes 0. So we stop here. add up all the quotients, right? So 20 plus 4 equals 24. So 100 factorial, the largest power of 5, which perfectly divides it, is going to be 24. 24 becomes the answer here. Yeah. What if it's not going to be just the largest power of a prime, but what if it becomes the largest power of a composite number? And this time around, we have a number like 135 dividing the same number 100 factorial, right? So for that, the steps are as follows. It's quite simple. Prime factorize first. 135 is 527, 3 cube into 5. So 100 over here. Find out the number of 3's over there. How do I find the number of 3's? Successively divide once again. 311. 3 over here is going to give me 3. And then 1. Number of 3's is 33 plus 11, 44. 44 plus 4 is 48. But I want 3 cubes. The number of 3 cubes is what? 48 in this case is perfectly divisible, right? 48 by 3 and gives me 16. If it would have been something like 47, no decimal, I can say there are 15 3 cubes. Extra 2, I don't do anything with it. Extra 2 3's, I can't do anything. Number of 3 cubes in 47 is going to be 15 only, I should have written. But here it was 48. So 48 by 3, 16 3 cubes. Now, how many 5's are there? We just saw it earlier. 100 successively divided by 5. That's the approach. We've seen that in the lesson. Number of 5's is 20 plus 4, 24. Right? What is lower of the two? We need to take the lower of these two. 16 is lower, right? So the largest power of 135, which is going to perfectly divide 100 factorial, is 16. I would take the smaller of the two because there are only 16 3 cubes. While there may be 24 5's, but only 16 3 cubes are there in 100 factorial. So 16 is the greatest power which divides. Yeah, simple concept over here. And moving to the next one over here, that pertaining to number of zeros at the end of a factorial, right? Number of zeros at the end of factorial. The number of zeros in a number, right? If you want to write it as 2 power 72 and 5 power 24 or 26 or whatever you want to write, right? Or 28. Number of zeros over here at the end of this number is going to be the smaller of these two powers, which is 28. Why? There are 28 5's which marry 28 2's and we get 28 zeros. When a 2 and a 5 are multiplied, you get a 0. That's when a 0 is produced. So what if it's something like 2 power 16 into, let's say there are a lot of 5's, 5 power 147. Can't help it. There are only 16 2's. We get 16 zeros at the end. Now, when it comes to a factorial, find the number of zeros. I need to find the largest power of 10 that is divisible by it. Now, 10 is made up of 2 and 5. Now, which is going to be more frequently occurring? 2. The smaller prime occurs often. 5 is going to be a lot fewer. So, therefore, to find the number of zeros, that's nothing but the number of 5's or greatest power of 5 that is going to perfectly divide the factorial. That's it. So, in 100 factorial, if I want to find the number of zeros, I just need to find the number of 5's and that's it, right? So 24 zeros in the end. Yep. Okay. So, but I had a lesson example, made this question, supposed to be a little complex, which can turn up, right? Something like this can come up. If n factorial has 19 zeros at the right before the first non-zero digit, 19 zeros is given, then which of the following could be the value of n? When you have options over here, start with something and substitute. So 75 over here, divide by 5, we're going to get 15. Divide by 5, we're going to get 3. How many zeros in 75 factorial? Has 18 zeros, right? Next, 75 to 79 factorial, right? 79 factorial is 75 factorial to 76, 77, 78, 79. There are no 5 multiples. It remains 18 zeros. 80 factorial becomes 19 zeros. That's what is asked. But 80 is not there. 80 factorial to which number? Just before the next multiple of 5, right? Which is 84 factorial has 19 zeros. because 80 has an extra 5 in it, right? 16 into 5, 80. To this, if you're going to multiply another 5 multiple, it produces another 0. 80 to 84 factorial. The number which is there is option 2, 83. Right, so 83 becomes the answer. Could be getting questions like this. You've got to be prepared for it. Yeah. Moving to the next major concept of this particular lesson, that's finding the last digit, right? How do you find the last digit? We've seen this in the lesson. Cyclicity, we need to remember. What are the cyclicities for, different cyclicities over here, 1, 2, and 4, right? Told you to write it down this way, initial stages, to remember the cyclicity, right? 0, 1, 5, 6. The cyclicity over here is 1, 2, 3, 7, and 8. The cyclicity over here is 4. 4 and 9 cyclicity is 2, right? Keeps recurring twice. So cyclicity of 1 is 0, 1, 5, 6. Here it's 2, 3, 7, 8, and 4 and 9. So what does this mean over here? If you want to find the last digit of 4578 to the power of 363, right? I'm concerned only about the last digit. Ignore everything else in the base. To the power, divide by the cyclicity. So last digit of 8 power 363 by 4. What's the remainder? I want only the remainder. That's 3. So 8 cube is 512. My last digit is 2. There's 2 over here. That's it. So if I'm required to find the last digit of, let's say this would have been 360. The only catch over here is this. If this would have been 360, then what is 360 by 4? Remainder, that's coming to 0. Can I say 8 power 0 comes to 1? No, that's not allowed, right? We're using a shortcut with the remainder, but 0 alone is not allowed over here. Now, if you're getting 0 as the remainder, add back the divisor 4. Add back the divisor 4, right? Then what happens over here? Then what happens? We're getting 8 power 4 over here, which is 4096, if you remember the powers. And we get 6 over here as the answers for the last digit, right? For each of these, the power can be divided by the respective cyclicities, and the remainder can be noted. If it happens to be 0, add back the divisor. Add back the divisor. Non-zero remainder has to be there, right? For the rest of it in the base, it's just the last digit. Just one quick example was actually the lesson example as well. 36 power 83. Cyclicity for 6 is 1, so 6 itself. 7 power of 10, cyclicity of 7 is going to be 4. So 7 to the power of 459 by 4. 459 by 4 is going to give us what? 459 by 4. So 3, right? And then a plus 8 over here. I'm looking at only the last digit. 364 divided by 4, remainder is 0, but plus a 4, right? And 4 cyclicity is 2. So 4 to the power of 84 by 2, remainder is 0, plus a 2, right? I'm skipping a lot of steps. The lesson, we've done it in detail, right? Remember cyclicity, if you know that, and then you start dividing them directly. You start noting it down. 7 cube over here is 343. I'm concerned only about the last digit. So 6 into 343, which is 3. Only the last digit I'm concerned about, and nothing else, right? Nothing else. Plus 8 power 4 is 4096. So 6. 4 square is 16. 6, right? And I want the last digit of 6 into 3, 18 was 8, plus 6, 6 are 36. So 6. 8 plus 6 over here is going to give us 14. So 4 over here is the last digit. That's it. So this question is clear. You're able to apply the cyclicity properly, divide and notice all these. Then right? Can pause at this and also see as to why we're getting the 0 and adding back the divisor. The concept should be clear with this. Okay. And going to the next one. Last 2 digits, where last digit is 1, 3, 7 or 9. The last 2 digits of a number, where you have something like 371 to the power of 468, right? The last 2 digits is going to be If it's going to be ending with 1, write down a 1. Then the tens place into units place over here. The tens of the base into units of the power. 7 into 8 is 56. 6. Right? 5 carry up, doesn't matter. Write 6 there and we are done. So the last two digits of 371 to the power of 468 is 61. Right? We've had a cat question before, asking us to find the last two digits of 2000. I think something around 2007 to the power of yeah. I'm not able to exactly recollect the question, but yeah, I'm trying to get that. Yeah. So that particular cat here, right? So I think it was something around 7 to the power of 2008, which is what was asked, right? Where this digit is not a multiple of, I mean, it's not ending with 1. So what do we do? What power of 7 is going to end with 1? It's going to be 7 power 4, which is 2401. So to find the last two digits of this, I have to write it as 7 power 4. Whole power what? The power to the divided by 4. 2008 divided by 4 comes to 502. And that's it. Follow the same process. 2401 to the power of 502. The last two digits over here is going to be 1, of course, comes from here. Then tens of the base, 0 into this. 0 into 2, 0 into anything is 0. So 01 becomes the answer, right? So this was the CAT 2008 question, right? Can turn up last two digits. When it's not 1, 3, 7 or 9, some power of it. 9 square is 81. 7 power 4 is 2401. 3 power 4 is 81, right? You have to use those to bring it to 1, apply it, apply the concept pertaining to 1, right? Tens of the base into units of the power. That gives me the tens digit. 1 remains 1, yeah? And then you simplify further, okay? Next, what if my last two digits are going to be, I mean, last digit is going to be 0. I'm asked to find the last two digits. That's simple. 70 to the power of 468. Last two digits are going to be 2 zeros, right? That's straightforward. Last two digits, when my last digit is going to be a 5. It's a simple part, right? So if it's going to be 45 to the power of 377 or something like that, whatever it is, it's quite simple. It's either going to be 25 or 75. When is it 75, right? When tens of base and units of power both are going to be odd. 25 if one or more are even, right? So that means 45 to the power of 377, 4 and 7, one of them is even. So this is going to end with 25. If you're going to have 57, I mean, 5, 7, 5 to the power 363, odd, both are odd, so 75. If it's 575 to the power of 362, even, moment you have one even, it's 25. What if it's 315 to the power of 643? Both are odd, then 75. But if one of them becomes even, then it's going to become, that's it, 25. What if both are even? Then even better, 25. Only when both are odd does it become 75, and that's it when it comes to 5 over here. Yeah. So moving to the next concept, last two digits where the number is divisible by 4. So if you take a number and the last two digits when the number is going to be divisible by 4, the number itself is divisible by 4, and then you raise it to some power. The concept is simple. The number is in the 40 number power 40k plus 1, right? The number power 40k plus 1, when you're going to be looking at the last two digits over here, is going to be the last two digits of the I mean, sorry, slight this thing over here. So it's going to be that of the number itself, right? It's the last two digits of the number itself. If n is divisible by 4, right? If n is going to be divisible by 4, we're going to be looking at the last two digits of the number itself, right? So what is the example we could work with over here? We could work with something like, let's say, 2016 to the power of 2001. The power is in the 40k plus 1 format. If you're looking at the last two digits, that's it. Straight away, we can write down the last two digits of 2016 because the base is divisible by 4. The power is in the 40k plus 1 format, and that's it, becomes 16. Does this turn up too often? Not very often, right? Not very often. Um, Again, when the number is divisible by 4, this can be done. What if the number is not divisible by 4 but divisible by 2? That is, the number is in the 4k plus 2 format. What are the last two digits of something like 86 to the power of 81, right? 40k plus 1 again. Then it becomes the last two digits of 86 plus 50, right? A flat 50 has to be added over here. X plus 50. Power has to be in the 40k plus 1. Doesn't turn up too often. Base is not divisible by 4 but divisible by 2. Even number. Then this is the thing. Last two digits of 136. It comes to 36. Just go through the lesson. If this is clear, this is clear. If it's not, it's fine. It's not a super important part, the last part over here, from the perspective of the exam. Okay, on to number systems. Quite a short lesson, right? A small concept only, nothing major over here. Roman numerals, typically, if they're going to ask us, they are going to define the values and give it to us. But just in case, I mean, it's not too difficult. I, V, X, L, C, D, M, right? These are the 7 letters which are used. I stands for 1, 5, 10, 50, right? And let's just write that clearly. 10, 50, C, century, 100, M, milli, 1000, right? And this is a 500 over here. So what would something like XXVII be? It's an additive number system, 10 plus 10 plus 5 plus 1 plus 1. All of them are in descending order. So everywhere you're just going to add them up and we're going to get a value of 27. But what if it's going to be something like this? It's 10, 10, 1 and 10. Now what's happening over here? It's not exactly descending. I mean, it's after 1, it's going up to 10 again. So it's supposed to be a minus 1 plus 10. When you have a smaller number before a larger number, you have to subtract it. So it's 3 tens and a minus 1. 10 plus 10 minus 1 plus 10, which is 29. Quite a painful number system to work with. And that's probably that is precisely the reason why we don't use this in actual life where it matters, right? With calculations, which is used to refer to sections and other things. Now, if you know this well, practice this well, and there is a question around this in LR or somewhere, or like even in Quant, you'll be able to quickly write down. 678 has to be written that way. LCDM, D has a value of 500. That's done. If you're converted to Roman numerals, and then you need 100 more. 500 plus 100 is 600. So that's from a C, right? DC, 600 done, 78. 78, L is 50 over here, right? L is a 50 and 28 is left. 28 can be 20, 2 x's, and then 8 we know, right? And that's it. That's what it is when it comes to 678. You don't need to necessarily remember this. If you're able to practice, you have enough time, then do it. Otherwise, it's just an area you can skip, right? If at all it's Roman numerals, they're going to define it typically in the exam. Now, if you have to convert convert from some other base to our base, right? Some other base to some other base to base 10, right? So how do we go about doing this? We have seen this in the lesson, right? Just use an example from there itself, right? So if we have 153 to the base 8, okay, and we have to add 136 to the base 14 to get some number in our base, which is 10, right? How do we do that? We just need to expand and write it, right? So the number systems over here, I'm not getting into the basics of it, right? Assuming that you know it and we're just revising. 153 to the base 8 is nothing but 1 into 8 square. plus 5 into 8 power 1 plus 3 into 8 power 0 over here, which is 64 plus 40, which is 104 plus 3, which comes to 107. 136 to the base 14 is 1 into 14 square, which is 196, right? Plus 3 into 14, which is 42, plus 6, right? 6 into 14 power 0, which is 6 itself. Now, 48 plus 96 is going to come to 244. And these two, if I add up, I'm going to get 351. How do I convert it to base 10? I'm already in base 10. I can add or subtract or apply the powers only in R base, which is base 10. That is all you and I know, and that is all you and I need to do. The moment you expand, you're automatically converted to base 10. You just need to multiply and add up, and you get the value in the base 10 format, and that's about it, right? So could there also be decimals over here? Could there also be decimals over here? Yes, other bases can also have decimals. What if you had a number like 101.11 in the base 2 number system, right? What happens over here? Once again, the same thing, 1 into 2 square, positional value, right? Immediate left of decimal is 2 power 0, 2 power 1, 2 square. To the right of the decimal is going to be 2 power minus 1 and 2 power minus 2. That's it. 1 into 2 square plus 0 into 2 power 1. I don't need to write it. 1 into 2 power 0 plus 1 into 2 power minus 1 plus 1 into 2 power minus 2. This is going to give us 4 plus 2 plus, plus 1, 1 into 1, plus 1 into 0.5, plus 1 into 0.25. And we get a value of 5.75. That becomes the answer. You could also have it with decimals. Chances of these turning up in CAT, I haven't really seen too much. I haven't really seen anything with respect to decimals, so don't know. But it could, right? Got to be ready with it. Okay. What if I have to convert some number from base 10 to some other base, right? Base 10 to some other base, we need to successively divide by that particular base and write down the remainders from bottom to top. That's the concept, right? So let's say we have the number 523, which in base 10 equals what in the base 8 number system. Take the number, successively divide by 8 and note down the remainders over here. So 8 into 7 is 56. No, 8 6 are 48, and then 43 by 5 by 8 gives me 5 8s are 40, and 3 remainder here. Divide by an 8, and you get 8 8s are 64 and a 1. And divide by an 8, you're going to get a 1 here and a 0 remainder. Divide by an 8, and you get 0 and 1. So bottom to top over here, 1 0 1 3. Bottom to top, not top to bottom. That becomes the value over here in the base 8 number system. These two are equal. That's it. Simple concept over here. Convert from some other base to our base, expand it. If it's from our base, you want to move to some other base, then you have to successfully divide that number by that base and write the remainders from bottom to top. Okay. What if we have something like a linked base, right? Linked base hardly turns up. If and if it does, you're going to be able to quickly answer. 156 to the base 8 is going to be what to the base 2? What to the base 2? You need to understand that 8 is 2 cube. What is a 1-digit number here is going to be 3 digits over here, 3 digits over here, and 3 digits over here, right? You're going to get 3-digit numbers. So you can, if you want to quickly write down, right, base 2 number system, what are you going to get? 0 is going to be 0, right? 1, 0, 0, 1 is nothing but 1. 0, 1, 0, right, is 2. 0, 1, 1 is going to be 3. 1 into 2 plus 1 into 1, right? So if you're able to quickly note those down, you might be able to quickly answer this, right? 1 1 0 and 1 1 1 is going to be 7. If you want to convert these, that's it. Pluck from 5 is 101. Put it over here. 6 is what we start with. Right, most 6 1 1 0. Put that here. and then 5 over here is going to be 101. So 101 and 1 over here is 001. That's it. The number is, ignore the zeros in the leftmost. 1101, 110 to the base 2 over here is what is 156 to the base 8. Only when it's linked up can you do. Now, if you're given something like this and you have to reconvert to find that, then you take 3 at a time. 3 at a time, and we have 3 digits in the base 8 number system. 110, right? 2 square, 2 power 1, 2 power 0. 1 into 2 square, 4. 1 into 2 power 1 is 2. 4 plus 2 is 6. In this case, 2 square and 2 power 0. 4 plus 1, 5. And here we just have a 1. This is 156 to the base 8. You can bring it back. So from a larger base to a smaller base, this is going to increase. Smaller base to larger base, this is going to reduce. And this is the way you can go about it. But again, it's a concept, but if it applies, I mean, if it turns up that way, well and good. Very rarely does it turn up this way, right? So that we need to remember. Okay. Now, what about adding and multiplying in different bases, right? Simple steps I've given. What are they? Product of 223 and 43, right? In some base, number system is going to give us 12031. What happens in our base? 3 into 3 is how much? 9. Are they matching? They are not. That's it. We stop over here. So what we can conclude over here is when I'm going to be multiplying 3 and 3, in our base we are getting a 9, but in some other base it is ending with a 1 and some carry up. So 9 over here is something. I mean, in some base, when it's ending with a 1 over here, right, should give me 9. So what can that be over here, right? So what do we have over here? Once again, so 3 into 3 is going to give us a 9 in our number system, yes, but it's going to give us a 1 with something carryover. Now, what is that carryover? That carryover, we don't know. It can be anything, right? Can 1 in some base be 9? It's not possible. Single digits have to be the same. So that carryover could have a value of 1. The carryover could have a value of 2, or it could have a value of 3, and so on, right? So what if it's going to be 1? If 11 to the base b equals 9, then what do I know? We know that this can be written as 1 to the base b. It's 1 into b plus 1. What is 2 to the base b? 2b plus 1. And this is 3b plus 1. 3 into the base plus the units digit. The tens place is always 3 into the base directly plus the units digit. So if b plus 1 is 9, then b can take a value of 8, which seems good. It's in the options. If 2b plus 1 is 9, then 2b is 8 and b is 4, right? 4 is not likely, because when 4 is the base, a number 4 can be used over there. It has to be less than 4, right? The digits used. For 3b plus 1 over here, after this point, we can stop, right? It's going to become smaller and smaller. B equals 8 is the only possible value over here. So option 3 becomes the answer. What is the logic once again? Where there is a conflict, we stop, right? So 223 into 43, 12031. But when I multiply, if I'm getting a 9, we stop here, right? In this number system, we wrote 1 and 1, something carryover. It could have been 11 with 1 and 1 carryover. It could be 21, 1 with 2 carryover, and so on. So any of these are possible. If these are going to be equal to 9 in our base, then expand it to convert to our base. B plus 1, 2b plus 1, and so on. If b plus 1 is 9, b is 8. 2b plus 1 is 9, b is 4. Not possible from here on. B equals 8 has to be the answer here. Yeah. So moving to the next concept, right? Quickly, something called skipping digits. Now, digits can be skipped. The classic question where it turned up one of the first times is ZAT exam 2011. Something called a micro nanometer, they called it. A certain factory can measure the pressure inside the gas chamber from 1 to 6 nines over here, right? 1 short of a million units. Lately, this instrument has not been working properly. The problem with the instrument is that it always skips the digit 5 and moves directly from 4 to 6. That means one digit is skipped. If one digit is skipped, it's a base 9 number system. And a base 9 number system, we're supposed to have 0, 1, 2, 3, 4, 5, 6, 7, 8. But this M&M micro nanometer is a different kind of base 9 system where it's skipping the digit 5. So it has 0, 1, 2, 3, 4. Till 4 it's the same. Then it's skipping 5 and going to 6, 7, 8, 9. Base 9 with different symbols. So what is the actual pressure inside the gas chamber when the micro nanometer displays 3016? You're supposed to do it this way and then convert from 3016 of the micro nanometer to watt of the base 9. Where it's 3, you put 3 itself. Where it's 0, you put 0 itself. Where it is 1, you put 1 itself. Where it is 6, you're supposed to put 5. Right? Because a different symbol, instead of the known symbols for base 9, 0 to 8 are used. It's 0 to 4, and then instead of 5, you're using 6. So reconverted, instead of 6, you bring it back to 5. Now this is in the base 9 number system, which we know. Now, how do you bring this? Now, what is the actual pressure? We have to convert it to base 10. Just expand 3 into 9 cube, right? That's how you expand. Plus 0 into 9 square, plus 1 into 9, plus 5 into 9 power 0. 3 into 9 cube is 3 into 729, which is 2187, plus 0 plus 9 plus 5, which comes to 14. And we get an answer of 2201 over here. Option 1 becomes the answer. Yeah. So on to the last bit over here of this particular lesson, that pertaining to special types bases 2 and 3, right? What are these special types? Two examples we've used. Ashi is given 158 and 1 rupee denominations. He's been asked to allocate them into a number of bags such that any amount required between rupees 1 and rupees 158 can be given by handing out a certain number of bags without opening them, by handing over. So you have to split 158 the way in such a way that any two numbers or two or more numbers you can add up to get any integer less than it. So we need to split it up as 2 power 0, 2 power 1. That's the condition, right? If you're going to break it down this way, then any number less than 2 power 4 minus 1 can be formed using these. One or more of the, two or more of these, one or more of these. We have seen this, right, in the lesson. So what is the largest power of 158? Largest power of 2, which is less than 158. We have 2 power 7. To bring it up to 2 power 7, we need till 2 power 6. Sum of this is going to be 2 power 7 minus 1, right? Sum of all the powers of 2 from 0 to n is 2 power n plus 1 minus 1, right? So that's 127. The last remaining bag over here is going to be 158 minus 127. We have a 31. So we have 1, 2, 3, 4, 5, 6, 7, and 8, right? None of these 8 bags are enough over here, right? So the minimum over here, it's a special type where we need to form, if you want to get form all possible integers by adding one or more of these, right? And what should those one or more be? They should be all 2 powers over here, 2 powers, and the remaining over here you put into the last one, and you'll be able to form any number between 1 and 158 using a combination of these, right? So that's the concept. Okay, moving to the last part over here, the last example. So that's where we use base 3. Now, base 3 over here, the concept of 3 is going to be included where 3 results are possible. Either you use a bag or not use a bag. That was base 2. Where you use one positively, you do not use it, or you use something negatively. 3 ways in which you can use it, and that's in a pan balance. So this is the example over here. Ram has a pan balance with which he should be able to measure all possible integral values in kilogram between 1 and 100. If he has a total of n weights, each measuring an integral value in kg. Now in a pan balance, you can use these weights on either side over here. right? So either side you can be using it on the left hand side or the right hand side. So so what are the weights required? Here you need three powers because you can use it on the left hand side or the right hand side or not use it at all. Three ways in which you can use it. So 3 power 0 is the first weight, 3 power 1 is the next, 3 square is the next, 3 cube is 27, 3 power 4, is there anything over there? No. So we can stop it over there, and the residual we can just um, you can just if you have a total of n weights, it's going to be this and whatever was left over here, right? So that's now going to add up to total of 5 weights over here, right? So therefore, 5 becomes the answer for this last question. Yeah. So on to the yeah, okay. So when it comes to surds and indices, the surds standalone questions in the form of surds are hardly there, but simplification of surds does happen a lot, right? Quadratic equations, quadratic or algebra, or like somewhere around even some geometry questions will have that. A lot of them involves conjugate and getting rid of the surd in the denominator, right? How do we get rid of the surd in the denominator? We multiply with the conjugate, right? So um, just take up an example over here, right? So where a and b are rational numbers, if 3 plus root 5 by 3 minus root 5 equals a plus root b, right? Then a plus 2b is what? Now, before I even get into that, if 5 plus 2 root 5, for instance, is x plus root y, then what are x and y equal to? X is speaking about the integer, that's 5, fine. But am I having root y? It's 2 root y. So take the 2 inside. So this can be written as if the 2 goes inside, it's going to become root of 2 square into 5. I think that all of you should know. When it goes inside the square root, we have to square it. 4 into 5 is 20, 5 plus root 20. Now I can say x and y are x is 5, x equals 5, and y equals 20. That's it, right? So given this, what's given here over here is a and b are rational numbers, and this is equal to a plus root b. I need to get rid of the surd in the denominator, so I multiply and divide by the conjugate. 3 minus root 5. This conjugate is 3 plus root 5. Right? What's the logic behind the conjugate? Um, I get the denominator the a square minus b square form, a minus b into a plus b, right? And what do we have here? 3 plus root 5 the whole square is 3 square plus root 5 whole square plus 2ab, right? 6 root 5 divided by uh, 3 square is 9 minus root 5 square is 5, right? And this is going to give us 14 plus 6 root 5 divided by 4, right? I can divide a 2 over here, and we're getting 7 by 2 plus 3 root 5 by 2, and 7 by 2 is 7 by 2, right? Plus, what can I get over here in terms of 3 root 5 by 2? I want to get everything into the square root. So 3, when I take it inside, it becomes a 3 square 9, 9 5s are 45. 2, when I take it inside, it becomes a 4, 45 by 4. So A is 7 by 2, B is 45 by 4. So 7 by 2 plus 2 times 45 by 4 is what is asked. So there's nothing but 7 plus 7 by 2 plus 45 by 2. LCM is 2. 7 plus 45 is 52. 52 by 2 comes to 26. 26 becomes the answer for this question. Conjugate is what we work with. Two concepts over here. If it's given the root B form, we need to understand that whatever's outside the constants, take them inside, right? Take them inside the square root. Okay. Going to the next one. Next one pertains to comparison of surds, right? I want to go through the surds part quickly. A is 2 plus root 8, B is 4 plus root 3, C is 5 minus root 2. Now, how do you arrange A, B, and C in descending order? We've seen that in the lessons. But quickly, if you have to write this down, root 8 is nothing but it's less than 3, right? Root 9 is 3, root 4 is 2, root 8 is 2 point something. 2 plus 2 point something is 4 point something. B is what? 4 plus root 4 is 2, root 1 is 1. So this is 1 point something. It's between root 1 and root 4. So this is 5 point something. This is 5 minus 1.4 or something like that. And that comes to 3 point something, right? 3 point something. What's it in descending order? Largest first, and then next largest is A, and then C, right? Write on what point something, and you can close it out, right? Now there could also be, if you want to compare between two of them, let's take two of them, 4 plus root 3 and um, 5 minus root 2, right? Which is greater. Just square both sides, right? And see what you're getting. 4 square is 16 plus 3, 19 plus 2 fours are 8 root 3. And here you get 25 plus 2, that's coming to 27 minus 27 minus 10 root 2, right? Subtract 19 on both sides. We're left with an 8 root 3. And here we're left with an 8 minus 10 root 2, right? You can divide 2 on both sides. You have a 4 root 3. And when you divide a 2 over here, we're going to have a um, 4 minus 5 root 2, right? And now whole square them. You can, how many more times you can whole square them and keep comparing this way, right? And what do we get over here? 16 threes are 48. And in this case, it's going to be 16 plus 5 root 2 whole square. That's like 16 plus um, 50. That's coming to 66 minus 2 into 4 into 5. That comes to 40 root 2, right? Now, which is greater over here? Again, 66 minus 40 is 26, but something, it's 40 root 2, it's something even bigger, right? Now, if you go down this path, it might be a little more, a little time consuming, right? So what is the treatment, what is happening over here? To check between B and C, I'm just, whatever operations I can apply, I can do, right? On both sides, square both, remove 19 from both sides, divide by 2 on both sides, and so on, till we reach the point where we are abundantly clear, right, as to which one is the greatest. But in questions like these, see if you can write them as something. So 5 minus 1 point something, 5 minus 1 point something, and 1.4 or something like that is 3.6 odd, right? That way, and you should be able to quickly close this out. Okay, on to the next concept over here. It's a very brief one. Square root of surds doesn't turn up too often. But how do you do it, right? So 9 plus 4 root 5. Uh, keep a 2 outside. Take the 2 inside. And you get 2 into 5, 10. That's it. Sorry, 4 into 5, right? Which comes to 20. Because one of the 2's I have to send inside. The other 2 I keep it over here. Because I'm trying to write it in the a plus b whole square format. A square plus b square plus 2ab. Now 4 5s are 20. 9 over here can be written as root 4 whole square plus root 5 whole square plus 2 into root 4 into root 5. That's it. We get a root 4 plus root 5, the whole square, and that is 9 plus 4 root 5. Right? So 9 plus 4 root 5 is this. If I want to find the square root of this, I have to find the square root of this, which comes to root 4 plus root 5 or 2 plus root 5. Right? Root 4 is nothing but 2 over here. But given that we have applied the square root, we need to remember that we have to go for plus or minus of this. It can be plus or minus of this, and that we need to make note of. Okay, so that's about it when it comes to surge, right? So now we look at indices. Now when it comes to indices, the basic rules, right? Basic rules are if a power x is equal to 1, then you know x over here has to be 0, right? Because anything to the power of 0 is 1. That's the only way that's possible, right? So if a power 1, you know, is a, right? Basics over here. 1 power anything over here is going to be 1. I think you know that. Minus 1 to the power of n equals 1 if n is going to be um, even, and minus 1 if n is going to be odd. I think you should know that as well. If you have something like a power m into a to the power of n, then you can add up the powers over here. And if you have a power m divided by a power n, that's a to the power of m minus n. Okay. A power minus n equals, again, I'm not explaining as to why and all, it's just division over here. A power minus n is 1 by a power n. A power m whole power n, right? Written this way is a power m power n, right? Sorry, a power m n, right? Multiply the two parts. It's going to be a power m to the power of n. That's what it is. Meaning, what's the difference? If it is 5 cube whole square equals 5 to the power of multiply the brackets, right? 6. It's 5 power 3 power 2. Start from the top. 3 square is 9. It's 5 power 9. Without the brackets, 5 power 9. With the brackets, it's going to be 5 power 6, right? So that's basically the basic rules, right? So when it comes to indices, couple of other things. If you're going to have a power 1 by 5, you can also write it as the fifth root of a, right? Fifth root of a. I think you should be knowing this. And if it's going to be a power 4 by 3, can be written as cube root of a power 4. A power 4 comes here. 1 by 3 becomes the cube root over here. And that's about it, right? The basic rules. Now on to the the more interesting part, which pertains to comparison of indices, right? How do you compare indices and say which is the largest, right? There's a standard type of question which turns up in exams, including the CAT, right? Which of the following has the largest value? Now, all of them seem to have are quite big, right? It's very difficult for me to find. But the powers over here are very, very big, but they're all multiples of some number, which we seem to know, right? Whatever operation I'm doing for one of them, I can do for the rest. So each of these powers, I would like to divide by the HCF of 96, 72, 48, 24. The HCF is 24. Divide by 24 everywhere. What are we getting over here? We're getting 23 power 1, 5 power 2, 3 cube, and 2 power 96 by 24 is 4, right? The powers, I'm raising each of them to the power of 1 by 24, or dividing each of the powers by 24. Now it's easier set of numbers for me to work with. 16, 27, 25, and 23. Question is which has the largest value? 27 is the largest here. Option 2 becomes the answer. So when the power is very big integers, divide them by the HCF of the powers. And then it becomes easy for us to compare. Now, what if it's the other way around? The powers have something in the denominator. Something in the denominator, then each of these I can raise to some power. I can multiply, the powers with something, and that will become the LCM of the denominators, the other way around. There I was dividing, so HCF. Here I'm multiplying, so LCM of the denominators. 8, 12, 16, 24. LCM is what? 24? No, 48. 48 is going to be, I'm raising each of these powers to 48. And what do we get? 1 by 8 into 48 is 6, 2 power 6. Here is 3 power 4. Here is 5 cube. Here it's 6 power 2. 36, 81, 125, right? And 64. The largest value, 125, 5 cube. Option 3 becomes the answer over here, right? Okay. So moving to the next one. Right. So moving to the general questions, right? That's about it from a surgeon and indices concept perspective. Questions around that in recent papers. If n is a positive integer, seventh root of 10 into seventh root of 10 whole square into seventh root of 10 whole power n goes on till there is greater than 999, then the smallest value of n is what? Smallest value of n. Okay. So first up, I have to write this as 10 power 1 by 7 into 10 power 2 by 7, right? 1 by 7. Just take it over there. 10 square whole power 1 by 7, right? So 10 power 2 by 7, and so on till 10 power n by 7 is greater than 999. So individual, I mean, if the bases are the same, the powers can be added up. 1 by 7 plus 2 by 7, so on till n by 7 is greater than what? 999 is greater than equal to. What is the next possible thing, right? Um, very close to some power of 10. What is that? 10 cube, 1000. Right? Just move to that. 999. What's one more than that? 1000, 10 cube. It can be equal to that, right? So let's see as to what n can take. So the bases are the same and it's more than 1. So you can get rid of them. So 1 by 7 into 1 plus 2 plus 3 goes on till n is going to be greater than equal to 3, right? 7 you can take it there. 21. Sum of any natural, some first n natural numbers adds up to 21. 6, right? 6 or 6, because 6 into 7 by 2, right, comes to 21. So 1, 2, 3, 4, and 5, and 6 over here. N can take the value 6. So therefore, 6 would be the smallest value of n, right? 1 by 7 plus 2 by 7 goes on till 6 by 7, which is going to satisfy this, right? So 6 becomes the answer over here. So how do we go about the powers over here? Greater than 999 to 10 cube. It's very close to 10 cube. You need to remember bases are more than 1. You can inequality continues. 1 by 7 you can take common. Sum of the first n natural numbers should be greater than equal to 21. It's 21 when it's first 6. 1 to 6 is adding up to 21. There we stop. 6 is the value n can take, right? So that's one. Just a couple more cat questions before we end this. So another one which came up, right? Quite an interesting one. This was the smallest integer n for which 4 power n is greater than 17 power 19, right? Holds, right? Is closest to which one? Now, 4 power n over here, 4 power n is greater than 17 to the power of 19. Um, and it's quite difficult, right, by just observing or looking at this. But what can I do? 17 is close to some power of 4, which is 16, right? 4 is 16 power half. So you can write as 16 power n by 2. This is 4 power n. 4 is 16 power half. So 16 power n by 2 over here. We can write 17 to the power of 19. Now, what about the bases? One is lower, one is higher. One is lower, one is definitely higher. Therefore, if the lower base has to be greater, the power should definitely be much higher than 19. N by 2 should be much higher than 19. That is all I can say with this. N should be definitely greater than 38. Only one option over there, which is 39. That becomes the answer. Exact value, how to find all of that. They don't even want that. They just want you to observe over here with one basic simple thing, that with a smaller base, the number has to be higher. The power should definitely be greater. And that's it. Yeah, so this is one interesting question. The last one before we end the session. This, right? So CAT has been having a tendency to come up with questions with indices, right? Where it seems quite complex, right? Seems quite complex. But how do we go about simplifying something like this? Next step over here when you're writing down should be quite simple. 2 power 19 by 2. Straight up you have to write it, right? 3 power 4, 4 square, right? 3 power 4, 4 square is 2 power 4. 9 power m is 3 power 2m. 8 power n is 2 power 3n. 2 cube whole power n. And you get 3 power n. 16 power m is 2 power 4m. And 64 is 2 power 6. 2 power 6. 2 power 6 by 4. 2 power 3 by 2. Right? 64 is 2 power 6. 2 power 6 by 4 is 2 power 3 by 2. Done. Now 2 power 3 by 2, if I take over there, the powers are going to be subtracted. 19 by 2 minus 3 by 2 is going to give me 2 power 16 by 2, which is 8. Right? These two, if we take to the side, it's going to become 2 power 8. And we have a 2 power 4, okay, into 2 power 3n, okay, into 3 power 2m plus 4 equals 3 power n into 2 power 4n, right? That's it. The 2's over here, what is going to become the powers over here? 12 plus 3n. For the 2's, 2 power, we are getting left hand side is going to be 3n plus 12. The power should be same on the right hand side, 2 power 4m, so it should be equal to 4m, okay. And what about the other one? 3 powers is going to be 2m plus 4 should be equal to n, right? You can rewrite this as 4m minus 3n equals 12, and this is 2m minus n equals minus 4, okay. We need to find m. We can get rid of the n into 3 and we subtract, okay. 4m minus 6m is minus 2m. 12 minus of minus 12 is 12 plus 12, 24, and we get m equals minus 12. That's it. Option 4 becomes the answer over here. Painful in terms of linking them up, but once you do that and the corresponding powers are equated for the left and right for the respective prime numbers, then two linear equations over here to solve it. I mean, those who feel that not able to understand, word problems are a little difficult and all of that, these are the questions you can give. You can give a go at, give it a go, and then you should be able to answer them. Might be a little time consuming, but should nevertheless get the answer at least over here.